The hoop stress at a point on the surface of thin cylindrical pressure vessel is computed to be 30 MPa. The value of maximum shear stress at this point is, see, this question is about thin cylinders, and this question is from GATE 2022 and question number 13 and of 1 mark. So here, the thing which we should know about the thin cylinders thickness, the thickness of the cylinder is very less. Okay, Venn diagram. Let me try to draw it again. Suppose, suppose you take a horizontally placed cylinder. Okay, now thickness is T, internal diameter is D, thickness is T. If T is greater, less than or equal to, you can say less than or equal to D by 20, so where D is internal diameter, then these are called uh, thinner vessels. Vessels means there may be cylinders or or spheres. Okay, so now thing is here, what the question is about. Question is about hoop stress, and the hoop stress is given, that is 30 MPa. So let us take any element. Uh, Let us shift to the new page. Suppose, okay, and now this is thickness. Let us say this is at 1. Let us say this is 1 cylinder cross section. Okay, at 1 point. So the remaining half I am drawing here, let us say. So another, this side is also there is, I am just cutting it. So I'll take one element here. Okay, one 3D element I'll take here. Okay, how, like this. Okay, so I'll take like this. Something like here also another cylinder, another element. Okay, so I'm taking in the longitudinal direction. This is longitudinal direction. Okay, this is longitudinal direction, and this is, suppose this is the center, this is towards any point on the surface, it is radial direction. Okay, this is radial direction. And other one is, if you take any element like this, I took this element now. In this element, how many faces? One is this face. Okay, this face. So whenever you take a cylinder which is pressurized, so the stresses at any point or at any element, they are all tensile stresses, because it is elongating because of the pressure which is inside. So that is why if you take this element outside, I'll just draw outside this element, okay, in big size. Fine. I'll draw, so same element. So this is, there is stresses perpendicular to this plane, right? And there are stresses perpendicular to this, that means this, and one is perpendicular to this. Okay, one is perpendicular to this. That means here. So now, if you talk about stresses in this direction, they are longitudinal. Longitudinal. And stresses perpendicular to this face, surface, they are radial. Okay, they are radial. And the stresses perpendicular to this plane, okay, they are tangential to the circle section. So, like this, perpendicular to this. So, these stresses are hoop stresses. Hoop stresses, these are radial stresses, okay, longitudinal stresses. Now, if there is pressure P inside the cylinder, if there is pressure P inside the cylinder, if that is the input, you can find out hoop stress, longitudinal stress, radial stress. So, how are they given? If the pressure inside the cylinder is P, then hoop stress sigma H is pressure multiplied by diameter divided by 2 multiplied by thickness, tension. These are all tension. Another one is longitudinal stress, that is given by sigma L. That formula is 4T, PD by 4T. Another stress is radial stress. Okay, radial stress, that is denoted by sigma R, that is 0. Okay, see here, you should remember the pressure is coming but radial, but that we are inducing that pressure by supplying some air or something, by pressurizing the air, that is given by us. But what are the stresses developed inside the material is longitudinal stresses, hoop stresses, because that is attached, there is another element above it, there is another element uh, behind it. But if you see, it cannot elongate in this direction, it can elongate in this direction or in this direction. That's why radial stresses are 0 in this, always. So now you know sigma H, you know sigma L. So from these two, what we can observe, sigma L is nothing but sigma H by 2, always. This is always. Okay. Now what should we understand? The is so I'll just uh, suppose there is a cylinder. Okay, there is a cylinder like this. Okay, so I'll show only this cross section first. So I'll completely draw one cross section, only circular cross section. Okay, now I'll draw another one. Is this is one. If you see from this view, you can see this, or if you see from this view, you will see only rectangle. Let us say there is a rectangle. This is longitudinal direction. Now, if I take any element here, okay, if I know, so what are these stresses? These are sigma H. And what are these stresses? Sigma R. This is sigma H and this is sigma R. Suppose if I take element here, what are these? What are these? This is sigma H again, right? This is sigma H because it's nothing but like this. This is that plane, okay? Like, and if you see this, these are sigma L, as I discussed in the previous slide. These are sigma L. Now, these are principal stresses. First thing. Second thing, here, if you want to find out tau maximum in the uh, that element where these are the stresses existing, in that element, one plane in that particular element will be subjected to maximum shear stress. Remaining all planes are less than that shear stress. So now how to calculate that? If you know the principal stresses, you can use sigma h minus sigma L by 2 if it is corresponding to this 2D element. Suppose if you take this element, you have to calculate tau max as sigma h minus sigma R by 2. Those are the principal stresses. Now, tau max at tau max can be written as sigma h minus sigma r by 2 or sigma h minus sigma l by 2. Anything. So at any point, if they are telling considering whole 3D stresses, by default, you should take this. This is the correct. Okay. But sometimes this can be correct. So if you are providing this answer in the GATE exam, that will be definitely correct. If you are giving this, if they are specifically mentioning only element 2D element in the longitudinal direction, you have to give this. If they don't mention anything, you can directly solve this equation. Now what is the tau max value? That is what is asked in the question. The hoop stress at a point is 30, sigma h is given, sigma L is not given, but maximum shear stress at that point you have to calculate. So, but from here we understood sigma L is sigma h by 2. So what do I do? First, I'll note down given data sigma h is 30 MPa, sigma L is sigma h by 2 as per the formula. So 15 MPa, then sigma r is anyway 0 always. So tau max should be sigma h minus sigma r. What is sigma h? Sigma r is 0 divided by 2. It should be 15 MPa. Or according to this formula, tau max should be sigma h minus sigma l. 30 minus 15 by 2, 7.5, 15 by 2 equal to is 7.5 MPa. So either this or this. If you provide this, undoubtedly it will be correct answer. Okay. So we'll go to the. So 15 we have got. If you give this, answer will be perfect. But the value of maximum shear stress at this point, if you are giving this, marks can be given, may be given, that we are not sure about it. But the final answer which I have to tell, if the chance is given, I will go for this B. B is the answer. Okay. Thank you.